problem na tayo. An aluminum conductor has a resistance of 50 ohm at 20 degrees Celsius. What is the resistance when its temperature rises to 36 degrees? So, itong problem na to, it involves temperature increase. So, ito ay nasa effect of temperature on resistance. Okay, so take note, yung mga given condition natin, which is the first or initial condition, at saka ano yung final condition kapag ganito. Okay, so natin yung mga given natin. So, an aluminum conductor has a resistance of 50 ohm at 20 degrees Celsius. Normally, ang normal room temp natin, temperature ay 20 degrees Celsius. So, initially, ang T sub 1 natin is, okay, T sub 1 natin is 20 degrees. So, ang compare niya is yung R sub 1, of course, which is 50 ohms. Paano natin na-identify na ito ang initial condition? First is, yung 20 degrees is the normal room temp. So, yan yung ating resistance, 50 ohms. Next, yung sinabi niya kasi dito that there is a temperature rise. Kapag sinabi natin temperature rise, ito na yung delta mo. Okay? So, delta T is 36 degrees Celsius. Kung gusto mong makuha yung T sub 2, that is, since delta T is T sub 2 minus T sub 1, so T sub 2 is T sub 1 plus delta T. So, T sub 2 is 50 ay 20 degrees plus 36 plus 36. So, that is 56 degrees Celsius. Pero anyway, sa formula kasi, ang formula natin is effect of temperature on resistance. It is R sub 2, R sub 1, 1 plus alpha delta T. Ayan yung formula natin. Hindi naman natin kailangan yung T sub 2 dyan. So, ang kailangan natin dyan is yung increase. Okay, yung change. So, that is 36 degrees Celsius. Pinakita ko lang, if in case you want to know what is the final room temp. Okay, kasi sabi niya, the temperature rises 36 degrees. So, yan yung tinaas, 36 degrees. So, kung ang tinatanong, required, what is its resistance? So, R sub 2, nung tumaas yung temperature. Check natin, meron na tayong R sub 1, meron na tayong delta T, okay, alpha. So, kapag may mga problems tayo na involved, kailangan nyo ng mga tables or constant. So, usually, binibigay ko itong mga to. Okay, for aluminum. Okay, this is from table. Alpha of aluminum is, in terms of degrees Celsius, this is the temperature coefficient of resistivity ng aluminum, which is 39 times 10 raised to negative 4 per degree Celsius. Ayan. So, this is our working formula. So, nakaayos na yung working formula natin. Isa-substitute na lang natin yung mga given conditions. R sub 2 is equal to R sub 1, 50 ohms. Okay, times 1 plus alpha. Alpha is 39 times 10 is negative 4 per degree Celsius times the change in temperature or yung rise in temperature. Ayan. Unit analysis. So, ito cancel out. Ito maka-cancel out. Ayan. Per degree ohm times degree Celsius. Per degree Celsius times degree Celsius cancel out. So, ang matitira is a unit in ohm. A unit of resistance. So, R sub 2 is in your calculator, 57.03 ohms. And so that's our answer for number 3. Okay, next problem tayo. Number 3, tapos 4 na tayo. Ayan, 4. Okay, so number 4, an incandescent lamp draws a 1.0 current from a 110 volt source of EMF. EMF is an electromotive force. So, same din siya ng voltage source. To rise the temperature of its tungsten filament to 2,800 degrees Celsius. What is its resistance at normal room temperature? So, again, sinabi ko na normal room temperature is 20 degree Celsius. Usually, lagi yan una natin condition. Okay, sulat muna natin yung mga given. So, ang ano natin, ang load natin dito is an incandescent lamp. So, sa loob ng incandescent lamp, meron tayong tungsten filament. So, basically, pinag-uusapan nating material ay yung tungsten. So, an incandescent lamp draws a, so meron tayong current na 1.0 ampere from a 110 volt source, 110 volt source of EMF to rise the temperature of its tungsten filament. So, again, yung 2,800 na temperature is a temperature rise. So, yan yung to rise. Wait. To rise the temperature of 2. Okay, T sub 2. Okay, mali. Ang 2,800 is the final temperature. Kasi sabi niya, to rise the temperature of its tungsten filament to 2,800. Okay, so ito yung final temperature. So, what is its resistance at normal room temperature? Basically, dun sa tanong na, may hint na tayo na ang tinatanong ay yung resistance R sub 1 kasi normal room temperature. Ang sinabi niya, required is R sub 1 at T sub 1 which is 20 degrees Celsius. So, ma-verify natin yan dun sa condition na we have a circuit. Okay, ang load natin is a lamp na may tungsten filament sa loob. Okay, let's say nag-switch on tayo ng circuit. So, dahil dun sa flow of charges, okay, magkakaroon ng current nga doon across a certain source. So, dahil merong flow of current or flow of charges, so mag-i-increase. Okay, mag-i-increase yung temperature. So, based on these conditions, itong mga to, which are final conditions, makukuha natin yung R sub 2. Okay? Tapos, makukuha natin yung R sub 1. Ang working equation pa rin natin is yung R sub 2, R sub 1, 1 plus alpha delta T. Okay. Meron na tayong delta T. Madali lang makuha yan since we have yung delta T natin is T sub 2 minus T sub 1. Both are given. Alpha, tingnan natin sa table. Okay, pero lalagay na natin. Alpha of tungsten. Tungsten yung nakalagay eh. Alpha of tungsten is yung temperature coefficient of resistivity natin is 0.0045 per degree Celsius. Ayan. So, meron na. Okay, ano pang kailangan natin? Yung R sub 1 is yung required. Kailangan natin yung R sub 2. So, yung R sub 2, ito yung condition na pwede nating magamit. Okay? For R sub 2, makukuha natin ito using this condition. Yung ating circuit. Okay? May circuit ka kasi. Ayan. Bali, ganyan siya. We have R. Ito yung resistance at temperature na 2,800. Meron kang source. Meron kang current I. So, makukuha na natin yung ating R sub 2 using Ohm's law. So, R sub 2 is V is equal to I R sub 2. Therefore, R sub 2 is V over I, which is V 110 volts over 1.0 ampere. So, R sub 2 is 110 ohms. Ayan. So, ito, a-arrange na lang natin yung equation natin. So, R sub 2 is equal to R sub 1, 1 plus alpha delta T. Okay? So, divide both sides by 1 plus alpha delta T. 1 plus alpha delta T. Kasi ang kailangan natin is R sub 1. Ang kailangan natin is R sub 1. Kaya ayusin natin muna yung equation. So, R sub 1 is equal to R sub 2 over 1 plus alpha delta T. Ayan. Ayan yung, ito pa lang yung working equation natin. Kasi ang required is in terms of R sub 1. So, ganun ang tip, no? Kapag hindi pa nakaayos yung formula, huwag mo na kayo mag-substitute ng mga given values. Mas maganda na ayusin nyo muna yung formula in terms dun sa required or unknown and then kayo mag-substitute. Okay, yung delta T natin ngayon delta T is 2,800, ayun, T sub 2, minus the normal room temperature, which is 20 degrees Celsius. Delta T is 27,780. Ayan, so R sub 1, substitute na natin. What is R sub 2? 110 ohm divided by, okay, 1 plus alpha. Alpha is 0.0045, that is from table, times delta T, 2,780 degrees Celsius. Okay, unit analysis, per degree Celsius times degree Celsius cancel out. Ang matitira is a unit in ohm, which is a unit of resistance. That is 8.14 ohm. So, this is our answer for number 4.